Good afternoon. Had to check where exactly we were at. I'm not sure if there's anyone walking by, but what a great opportunity we have here to kick off the afternoon at the Clean Resource Innovation Network Pavilion. A very accomplished panel, certainly, but I think why most of us are here, guys, I hate to say this, but we're here for the Deputy Minister at the end of the day. But Deputy Minister Paquette is someone that certainly takes engagement very seriously and really does a heck of a job bringing folks in like these guys and myself and many others to the conversation to ensure that she understands how the government can support innovation, technology, and certainly Alberta's objectives and how we can all support it. And so without further ado, Deputy Minister Paquette with a few comments to get this session going.
Thank you, Jackson. This is a really long mic. I think I got and good afternoon. I'm of environment and protected area, as Jackson said, and Albertans. So proud to see our province emissions continue to reduce as our energy sector grows and see all these delegations. I think we have one of the largest delegations. Truthfully, we are everywhere, which is wonderful, telling Alberta's story. By collaborating with innovators like Petroleum Technology Canada, PTAC, the Methane Emission Leadership Alliance, Alberta Innovates, Tourmaline Oil and Natural Gas Innovation Fund, NGIF Capital, Alberta is meeting our goals and keeping our energy sector thriving while ensuring affordable and reliable energy for Alberta, for Canada, and for the world. We can always accomplish more by working together. Absolutely, we can always do better, but we are doing quite well by world standards. This spirit of collaborations and efficiency is what gives Alberta its competitive advantage and also entrepreneurial spirit. For those who know me, I used to live in Middle East, and I can tell you one thing, there's a lot of synergies between the two countries, United Arab Emirates and Canada. The entrepreneurial spirit, the ability and willingness to adopt new technologies. And I see two gentlemen, one of them for Carbon Connect. I originally met in Abu Dhabi from all places because we both are from Calgary, which is interesting in itself. What I'm trying to say, we travel and tell Alberta's story. And our leadership on reducing methane emission, it's prime example. Now, I don't know how much you guys know about methane. Well, I didn't know a whole lot when I first accepted the position. So methane, known as CH4, is the second most abundant GHG after carbon dioxide. And it's way more potent. And it accounts roughly, and audience will correct me, I'm pretty sure 16, maybe more % of global emissions. However, due to its structure, it traps more heat in the atmosphere than CO2, making it 80 times more harmful than CO2. So it is important. And yes, it has half-life, which is way shorter than CO2. However, it's that much more important. So Alberta was the first oil and gas producing jurisdiction to put requirements on emissions from flaring, starting as early as 1990s, really. This approach is now considered best practice winning nationally and internationally. Really, without the regulations, there's no incentive to really reduce those emissions. Alberta was the first province in Canada to set methane emission targets for specifically oil and gas sector. We committed to reducing this emission by 45% from 2014 level by 2025. And I think everyone here knows the good news. We did it two years earlier. And I think we are at more than 45%. And again, I would have to ask my Alberta Energy Regulator colleagues, but they are telling me we're somewhere around 46 to 47%, if not more. Alberta's success lies in action, not just aspiration and conversation and setting the targets. Here's what we've done, why we met those targets. We agree with federal government, and I'm very hopeful that that's going to happen again, on equivalency. That means allow us to do it our way. And this is how we do it. We went to industry and asked them, how can we do it? And they told us, that's why we were so successful. That's the difference. So our policy approach, which includes regulation, market-based incentive, and investment programs, it's supporting faster and deeper reduction and keeping our industry competitive. Our regulations are truly innovative, offering flexibilities that encourage optimization and technology uptake to drive effective costs and credible methane reduction. Again, the government here, it's not an expert. We are asking experts how we can do this best to really have a tangible results. And there was a lot of work done. And again, I'm looking at Carbon Connect in regards to baseline. That's how we measure. We need to start somewhere, somehow. So an Alberta Baseline Reduction Opportunities Program has inventory of almost 15,000 sites. And I'm looking at the people who actually done this for us. So thank you very much. So we have this inventory of over, again, 15,000 well sites and facility across our province. So we are pretty good at measuring methane. This helps operators create their own baseline and identify their own methane emissions reduction projection and projects and projections. These are all fantastic in impactful provincial programs that are empowering industry and truly yielding impressive results. That's why we are leading in regards to methane emission. But we don't do this work alone. Alberta's success the technology develop and commercial on this panel, all of you. So thank you all, gentlemen. PTAC has launched hundreds of innovative research and development initiatives that advance hydrocarbon production in the most economic and environmentally sustainable matters. Thank you. It's impressive that PTAC has done what PTAC has done to support the development of or demonstration of technologies that are capable of reducing methane emission, and I'm told by 48%, maybe more. Well, we'll chat later. The Methane Emission Leadership Alliance is Canada's most complete source of data, technologies, and solution providers, and is making amazing strides on methane monitoring, measurements, and reduction. And tourmaline success, collaboration with key industry partners to advance a new first-of-its-kind emission testing center in extremely impressive. So thank you. I don't know about cost. We can talk about that, but I don't think it's that much. Not only is all the work so important cutting emission, it's demonstrating that our industry and Alberta can and will lead the energy transformation. Our province is fully committed to responsible energy production and the development, really. And I always say, whoever hangs out with me, world needs more Canadian energy, truthfully. Alberta is focused on reducing emission while removing barriers and building on the practical innovation that are already underway. We will continue to set new targets and work to cut even more methane emissions as outlined in the province Emission Reduction and Energy Development Plan. And I have to pause for a moment here. Very proud of the plan and my team who is sitting with us today. The first sentence in this plan, it tells the story. This plan is to cut emissions, not economic growth. And that's truly what we are trying to accomplish. Our plan commits to engaging with industry, Albertans, and Indigenous organizations to look for pathways to achieve a provincial, and now we are told it's going to be 75 to 80%, but as Albertans, I think we can do it. I'm being told by the industry we can do it. And we continue to use pathways that combine the regulations, market-based incentives and programs, complemented by continuous improvements in measurement and reporting. We all know there is a need for ongoing research and development to address technology gaps. And my conversations with my friends from Alberta Innovates. So John, I know you always try to show me new solutions, so thank you for that. So we must continue improving measurements, monitoring, and reporting of methane. And we must continue collaborating. There is no one-size-fits-all approach to emission reduction. Jurisdiction must be open to sharing learning and best practices like we are doing here this afternoon. And that's actually a very good statement too, because who knows more about Alberta and our industry than the people who are living in Alberta, who are truly creating those emission reduction and creating this industry. So it's very important that we have a say how we do that. Other regional governments across Canada and the United States have reached out to us to collaborate on methane emission reduction simply because we are known as a subject matters and everyone else knows we are pretty damn good at it. Increasing awareness about the impacts of methane emissions, opportunities to reduce those emissions, and integrating satellite and other remote sensing data to detect and respond to methane leaks faster. This is a prime example of teamwork and innovation required for all of us to reach our environmental goals. So there's a lot of new technologies, and actually I'm gonna just park at one question for panel, just because I might need to be transferred to another panel. But the satellite data, what can we do to improve the data quality? So that's a question for today for all of you, because I'm very curious and I'm looking into this. So we are all here at COP because we believe in partnership and cooperation and learning what can we do more and better. Whether research innovation are led by academics, industry, governmental, or multi-stakeholders partnership, we must work together. In Alberta, our economy and our livelihood are sustained by our natural resources. We are very fortunate to have them, and our province is thriving thanks to industry leaders like those here today. And I'm just looking at the crowd. Thank you for all the work you do. Sincerely, thank you for all the work you do. And let's keep working to drive a more sustainable path forward and in better future for Alberta, Canada, and as a matter of fact, for the world. Thank you again for having me, and I will pass back to you, Jackson. And I don't think you need any introduction, so.
Thank you so much, Deputy Minister. If you wanted to moderate the rest of the panel, by all means, you did a unbelievable job setting the stage for us here, and the group of panelists that we have that I stole their best pictures off the worldwide internet. And Scott in particular is very happy about this. But you know, it's so without further ado, I think Deputy Minister, thank you again for setting the stage in a way that really allows these gentlemen to talk us through the next steps and how do we move forward towards the 75%. And John Zhao will, with Alberta Innovates, will talk us through some of that.
Well, thank you very much, Jackson. And can I have my slides, please? So yeah, I guess with that introduction, I really have a very easy job. The story I'm going to tell you is actually probably something you may not aware of. The most successful methane emission reduction program is actually Alberta federal government collaboration. It's a joint program. It's called CERIN. It's so we are in the CRIN pavilion. So that's CRIN Resource Innovation Network. But we have also a program called CERIN, which is the Canadian Emission. Can I have a next slide? Oh, okay. Oh. So I probably don't need a slide anyway. I can continue. So yeah, it's a joint program. Essentially, about 2018, we realized, Alberta Innovates realized there are lots of good methane emission reduction technology is being stored. They actually cannot advance because they cannot be tested in the field. There is no such a facility. So that's why we get together with NRCan and we started to put a program together. And through that competition, we actually get PTAC and Natural Gas Innovation Fund, two programs together, two largest, I guess, collaboration opportunity or programs in that system. I think the Sohail and John is going to talk about the detail of that program. But overall, we set up a very good, competitive program. We had set up a platform essentially for the technology provider to test their technologies in those facilities, but also for industry to get together, provide a forum for them to ranking their challenges and opportunities, and ask the innovators essentially to provide solutions. So that is essentially, again, the story Sohail and John will provide. So again, my job is very easy. I guess my slides are up now, so maybe I can tell you a bit more. Yeah, so the only thing I want to talk about more is, in this program, we actually have $1 billion of $1 billion facility actually made available for this program. Anyhow, I guess I don't think I need to say more. I will let Sohail and John take over. Thank you.
Thank you very much, John. Really appreciate the support of Alberta Innovates and of course NRCan and so many others. May I have the slides? So what I wanted to talk to you about, John started about 2018. I want to go back to 2008, 10 years before that. That was the time that we launched the development and field testing of a methane reduction technology. Back then, very few were thinking about methane and its impact. So for this, we formed a consortium, and the technology that we were field testing was asparatin. And what happened here is that the consortium had 10 producers, and we went from field to field to excel this technology. Because when you move from one set of criteria like the settings, the operational, geological, etc., you are running into major challenges. We wanted to make sure this technology is going to be applicable across the board, everywhere. So we did that, and this technology currently, by the way, is reducing methane emissions equal to taking 170,000 cars annually off the road, while $20 million is saved for the industry because they are, rather than venting that methane, they are consuming it in the field. So the story is that what Kasia was talking about, she's absolutely right, and her profound statement was about we need to make these things economic. We need to reduce emissions and make money, and that is where innovation comes into play. So moving to 2018, we did 60 more technologies, the same way that I described first. And then, but the challenge that we had for each of those technologies, we have to go knock at many doors, talk to producers, talk to others and try to form a consortium and then field test those technologies. And then secure funding was another challenge. I came up with this thought of creating what I call a consortium of field testing facilities. So for that, essentially, if I have the next slide, please. So for that, essentially, I contacted 16 producers and 16 universities and research centers. And I asked them to come and contribute their facilities worth over $1 billion, as John mentioned, to this consortium. Now, those 16 producers are now 14 producers, 2 of them merged, etc. But those, along with those university guys and research centers, they provided these facilities. And then I approached John and approached NRCan, and I said, you know what, we need money to pay for the operations of these facilities. And they generously provided that. So at no cost to technology providers, we were able to field test the technologies. And that is a major accomplishment which would not have happened without the support of Alberta Innovates and NRCan, and also early adoptions by producers to make it happen. So where are these facilities? As you can see, they are from south to north, west to east, and they cover all type of various reservoirs, operations, etc. So then we started this CAN. Essentially, that was the CAN ERIC program in collaboration with Alberta Innovates and NRCan. Under that, we did 31 field tests again and increased the capacity to the 48% that Kasha mentioned. And that 48%, the question of it is then how much of did really contribute to the actual methane emissions? One thing to mention that the funding actually came 70% private, 30% government. Without the government fund, we would not have been able to do this. Here, these are the list of those 30 projects. This is 16 of those projects. And then this is the remaining 15 technologies that have been so maybe I should, okay, the intensity of so it is the emissions per, as you can see, that red line is at the beginning of when Alberta actually started reporting methane emissions. And you see that big line coming down. All of those, majority of it happened actually because of the early adoption. And then what happened? The government regulations and incentives kicked in, which really accelerated that and kind of increased the amount of actual emissions that we could have. And then, so this essentially shows the success of this program and the current support. So where are we going from here? Very simply, there are 6 sources of technologies or areas or sources of methane emissions that we really need to develop. Tanks, methane slip, surface casing vent flow, leaky wells, catalytic heaters, flaring alternatives, and then novel pneumatics. And essentially, in conclusion, these technologies that have field tested played a fundamental role in the actual 45% reduction of methane. The second notice is that essentially significant knowledge gaps remains to achieve to 75%. We have already gone through low-hanging fruit. Now we are dealing with much more complex area that requires more sophisticated technologies. The third bullet points is talking about the CAN ERIC 2 program as developed to reach 75% reduction by 2030. And the last point is that methane emissions innovation ecosystem built with the broad network of governments, producers, academia, technology providers has delivered tangible results and continue to grow. and is ready to tackle the 75% reduction. Thank you.
Thanks so much, Sohail. Mr. John Adams, you're up next. Oh, look at this guy. All right. Well, good stuff.
You have to come up to Scott after me. Well, why don't you stand here, sit there, and then we'll. So, good afternoon, everyone. My name is John. Oh, so that's a little bit higher. Yeah, I think. Testing 1, 2, 3. Hi, so my name's John Adams. I'm the CEO of NGIF Accelerator, and also feel like it's echoing a little bit. Why don't you just bring the mic over there and you can come up after? Yeah. Oh. Maybe it could be. So, so let's go to the next slide. So I run two things: a technology accelerator, and I run a venture fund, both pointed towards clean technology solutions for the natural gas sector. And our technology and innovation fund, we have granting to startups that have de-risking technologies for the natural gas sector. We also run an emissions testing center program that we're going to talk about right now. Our program itself is essentially collecting many different emissions reduction technology companies from Canada, North America, from around the world, and inviting them to come into our program, which essentially is going to de-risk and validate those solutions and get them closer into the natural gas market. Go to the next slide. So as John Zhao mentioned, we also put an application into the CERIN call for proposals. Our proposal was to build a sort of focused center of emission reduction technology companies and a sort of network of emission source points on a single live gas plant production system. And so we put together a consortium of industry, government, and academia. They're sort of listed there on the side, and you'll see a little bit more as we go through. And this consortium essentially was going to allow for a no cost to the startup program where a startup could come to us through a process, which I'll talk about, a university setting as well as in a live setting. So we received John Zhao's work. We had 9.25 million through the program directed from NRCan. And we used that money essentially to instrument the University of Calgary labs, the tourmaline perpetual site, and extended tourmaline operations so that we could have not 10, not 20, not even 30, but a huge network of methane emission reduction technology startups so that they could validate their technologies. Next slide. The model we built for the program, because it's a program, is to come in through an intake process. And again, we're seeing technologies from all sorts of locations with all types of subsectors of methane emission reduction technology companies. And then we, to be able to get them to the site, the live site, first we have them simulate tests at the University of Calgary and their labs, which Scott will talk about. Then we have a field testing side of the program, which allows for the startups to then spend sometimes a month, sometimes a year or more at the tourmaline site. And afterwards, they come out of the program with a report that they can take to investors, to future customers, and allow them to continue to their path to commercialization. Next slide. I'll turn over to Scott, and you can talk about the two host sites. Okay.
Thanks, John. So my name is Scott Volk. I'm the Director of Emissions and Innovation at Tourmaline. We are the host site of the Natural Gas Innovation Fund Emissions Testing Center. So we'll start out by kind of telling you what all the different facilities are that build the network of the Natural Gas Emissions Testing Center. The first being at the University of Calgary. At the University of Calgary Research Center, we have a series of lab spaces where we do early kind of research and work on both modeling and simulated testing. So that would include a variety of different testing and different things. Usually when we bring technology there, it's before it has CSA approval. Early development all happens at the U of C lab. And then if we go to the next slide, we'll show you the emissions testing center. So the emissions testing center, the hub of it in the field operation is the Tourmaline West Wolf gas plant. It's a modest gas plant. We've equipped it with over 150 different flow meters and sensors, so we know the exact amount of emissions that are on location. We believe it's really important when testing technology that it happens on a live operating facility. That way you get to see real life applications and it's fully instrumented. All the little dots around that plant are showing environmental sensors. Those environmental sensors are used to help support the emissions testing. So we know exactly what the methane is, what the environment is, the pressure, wind direction, and everything while we do different tests of different technologies. Along with that, we also have a vent site. So the vent site is just offsite of this location. It's a completely controlled site. There is no methane, so that's where we do quantification work. So a lot of detection work is focused at the gas plant, and then when we're trying to help companies that are looking to quantify the amount of methane, we have a site where we have an exact known amount of methane there as well. And people that are familiar with methane and kind of some of the new things that are concerns, we also look at methane slip. So in order to do methane slip research, we built a trailer. So this is a trailer mount system that'll do continuous emissions monitoring. So that moves around to different engines, and we can do testing on engines, testing on catalyst, testing on all sorts of different technologies used to mitigate methane slip. So I'll leave it there. That brief introduction, we do a lot more at the ETC than just that. We have brought a number of different technologies through it. We're happy to be a part of the ecosystem and helping to reduce emissions.
I really can't say enough about what a great initiative this is, and it's been years in the making. It's been ongoing now for, I think what are we, John, 4 years, 5 years. It's actually one of the best examples we have of everybody here and all the technology providers really working into their strengths, because the concept came up through John and his team as well in collaboration with NRCan. So having that federal provincial engagement on this and it enabling the research that was required to say, here's the avenues that we should consider for some funds that we have. So really leveraging the minds that are looking at the innovation system and saying, where can we help promote what we need to in order to ensure that we are building clean technologies and promoting a clean energy sector. And then when you look at what Sohail and his team bring to the table, it is really bringing a lot of people to the table and understanding how to build networks and then ultimately deploy funds into that network to enable so much activity. And certainly John, is very good at bringing people together. And certainly, I mean, John, we've been talking about this since you really were getting going and how to draw in the largest natural gas producers into a space, and then getting Scott and Tourmaline on board. And I cannot say enough about what Scott and his team have done, certainly without me having met the field folks, but I can only imagine what their commitment level is to this type of initiative. And we certainly can't ignore how important it is to have the field folks on board, but to have a site that is a live site that is testing these technologies is so extremely unique and extremely helpful as we can continue. And I say we collectively, because one of the organizations I'm involved with is very intimately involved with the testing center. To be able to keep bringing project or technologies in is just a wonderful opportunity, and it really shows where the longevity of that initiative can be. So let's actually, guys, let's first answer, and John, I'll start with John Zhao. I'll start with you on this one, but if there's other comments, it's Kash's question. So satellite data. Okay, satellite data largely is behind a recent study that said, well, actually, guys, hold on. Sohail, is your graphic really what's happening, or are we understating the emissions profile in the sector? And a lot of that research that's been done recently is based off of satellite data. And if we had 3 hours, we could talk to you about some of the limitations around detection technologies. That's the whole point of this. But John, what do you make of the fact that there's some very public research that's coming out that's indicating largely that our emissions profile is very much understated. Oh, sorry, John.
Thank you, Jackson. So many of you know my middle name is the BBC, so I've been pushing the BBC program for the last few years. But you know, the methane emissions is something I spend less time of. So this paper recently by Professor Matt Johnson, I think certainly it's very interesting. I think it's you know, certainly there is space that is need for those kind of research. It's a top-down approach versus bottom-up approach, right? So both approach are useful, necessary, but I think there is a couple of things need to be considered. One is the uncertainty of that measurement, which there are 6 of them, which is actually acknowledged by Professor Johnston in his paper, and some of those are involved in you know, the time because those emissions are not necessarily doing all the time, emitting all the time. And the second important thing is involved estimate that is about 30% of emissions is estimated from the data which is not there. So the argument is the detection limit is not sensitive enough. Therefore, you have to have added sort of extra amount, and that is really a bit of challenge. And as a third one related to that a challenge is the intensity calculations. You know, the paper talked about in the BC, the emission intensity is lower, and in Alberta it's slightly higher, and Saskatchewan is worse, essentially. And that is essentially mostly related to the production mode, because in BC is mostly natural gas production. In Alberta, you have oil and natural gas. And in Saskatchewan, there is lots of heavy oil production, which emit lots of natural gas methane emissions. And that essentially led to the differences between those provinces' intensity. So again, you know, in summary, there is, you know, certain value in those kind of approach, but there is lots of work needed to be done.
Yeah, thanks, John. Scott, do you have any commentary around the satellite data and what's actually happening in the field?
Sure, I can make a few comments. So we have had GHGSat come and test at the Methane Emissions Testing Center, and Tourmaline also purchases GHGSat data, so we get a little bit of information on Canadian satellites. What you'll find is you only see large emissions from satellites. There's very few emissions in Canada that are detected by satellites, but there's lots of emissions around the world that are. So Permian, for example, we have data set there'd be in the thousands of events found every few months. And then you've got other areas such as Turkmenistan that are really, really significant on satellites. So I think the satellites are moving to where they're going to be more of a open platform where you'll be able to see all sorts of information, and it will become open data. Right now, they are a little bit limited as to what they can find as far as large releases, but it's a future point where you will see all the data transparently across the world, which will be great for Canada because our performance and things like this will actually be seen worldwide and put us at a level playing field.
Thanks, Scott. Sohail, do you have anything else?
So thank you, actually, Scott, for that information. What is happening right now is, of course, satellites, there is a challenge in terms of getting really small emissions measured and reported. But the technology is advancing in 2 ways. Number one, the way that we are processing and analyzing the data is changing big time. at Waterloo, they are working on this, and now they are actually trying to even get meaningful information from those satellites that you can get information free of charge. The second thing is the sensors. Sensors are changing too, becoming more sensitive. And so then you are getting more information from them. So in my opinion, we are not there, but I would expect in 5 or 10 years, we will be able to get really meaningful information from satellites. With respect to the second question, I guess, with respect to are we measuring the right data, etc. The way that, I mean, this goes back to the way that ECCC has been measuring information or reporting, etc. The majority of the reporting was based on engineering calculation, wasn't about actual measurement. So they had a bunch of formula, and then they would just say, okay, here it is for certain emissions sources, and then they would calculate. We know that those engineering calculations were not correct. Why? Because we have already measured them. We know what they are. Those are changing. And actually, the Alberta regulator, the AR, is now started reporting them on measured emissions gradually more and more and more. And so we are going to see maybe a year or so that all of the information would be most likely would be through the actual measurement. And that would be then very accurate, etc. Technology is changing, so you can combine technologies together to also get more accurate information. You can get information from satellites and then get information from, say, drones, etc., and then use artificial intelligence and AI and machine learning to really get more meaningful information, not only in terms of actual information, but you may get to a point of being able to predict and kind of expected behaviors. Like, for example, tanks, they have unexpected behavior. All of a sudden, you have emissions coming and nobody knows why and how. Well, if you can link the whole thing back to the reservoir, what is happening in the reservoir all the way to the point of emissions, then I think there is a chance to also use artificial intelligence to get that information. So thanks.
Okay, thanks, Sohail. So maybe we'll pull on that thread a little bit, and John Adams, we'll move it over to you. Is how do we, because we have Alberta Innovates here, we don't have NRCan, I don't think, but geez, wouldn't it be great if we could convince them to keep this going? So, you know, how do we look at the continued growth for the next 5 years and you know, work off of the great work that's already happened to date, but how do we keep progressing this along?
Sure. Just on the satellites, we are at NGIF, either it's our granting organization or the venture fund. We're seeing new applications, new satellite opportunities coming forward, not just from Canada, but from other parts of the world. I think GHGSat has some big news, and other companies want to follow that route. Just on the sort of the go forward pathway, you'll see it at our center, and certainly want to talk about it more. We're seeing many different categories of methane emissions reductions in those buckets. There's many technologies that are within mitigation or measurement or reduction. And so I think the growth in the next 5 years is to see those companies either have a 2.0 version of what they want to do, or sometimes a sort of an integration of some of those technologies to get us, you know, to that last mile, to that 75%, which, as I think Sohail mentioned, like that's the last mile type of stuff, and it's often the hardest stuff. So I think you're going to see, I know at the center, we're talking about aspects of growth there, which will be sustainability. We want to see more, we want to be able to, the longer we can keep the no cost to the startup opportunity, the more we are bringing technologies forward. And so the growth of the center and the growth of the need to make the next 5 years is going to be linked to our ability to keep that center running and bringing more technologies in. So some integration, some 2.0 versions, and just, you know, being even more efficient to get that fine tuning of those missions.
Scott.
sorry, just want to add a little bit to that. Like the government, industry, everyone got together. This initiative is incredible in order to hit the 45% target. When we set that target, we didn't have the technologies to hit 45%. We all worked really hard together and we got there. And now we're at the point where we definitely do not have the technologies to hit 75%. So we're starting over again. We need those technologies. We need all those brave people to go mortgage their houses and build something new and take a risk. So this is where we're at. We need to do the same thing. We need to hit the 75% target. And to do that, we need the technologies to be there for us to do it.
John Zhao, do you have any other comments on how we can get more money from Alberta Innovates? That's not BBC related. Okay, go on. Laura, you can comment too if you want.
Well, yeah, I was going to say my CEO is there, so make sure you talk to her. But I guess one thing though is I should point it out. We actually have mapped out. I think I said actually I'm taking credit from Jackson here. Jackson actually did a study for us recently, looking at this the load to 75, as Scott said, the technology are not there, but we know what we needed to hit to get a 75. And actually Jackson mapped out that pathways to get a 75%. So yeah, I guess maybe John and we should working together and try to convince the federal government to come in again and pursue 2.0.
Yep.
So
Thanks, John. Sohail?
Yeah, I mean, I really agree with what John and Scott mentioned, and also the other John, which is, it has been a tremendous success, and now we are dealing with a major challenge. We definitely funding from government would help, but the other thing that can help big time is collaboration, and I'm talking about international collaboration. The US right now is spending huge amount of money on methane. We have started contacting them, and I think we are seeing some really good opportunity in terms of collaborating with the various organizations in the US that are way behind us, but I would expect that within a year or two, they're going to surpass us, the way that they are investing and the way that they are looking at that. Same thing, we are working closely with England, with the Net Center in Aberdeen, and that is again a good collaboration, because in my opinion, if we don't collaborate, we're going to duplicate. And that is something that we can't afford to waste money on research and development. We gotta work together.
Justin, I don't know if you stepped away on purpose at the time that we were trying to get more money up here. So you did, yeah. Don't say that so quick. We're only halfway through our pitch, all right? But no, it's I like that, Sohail, that comment around the international collaboration piece. I'd love if there's any other comments from the other gentlemen around that. We're here at COP, and even keeping it more local within talking about the US, and the METEC facility in Colorado very recently came out and publicly communicated that, look, we are not an active facility, because there was a lot of misinformation out there that you could go down there and test technologies, and that information was going to be good enough to go out and secure funding and really pitch your solution. But then lo and behold, we go through this process and we actually have an ETC that's a live facility. So what do you think, Scott?
Well, one of the great things is METEC reached out to us, to the NGIF facility, and asked if we can collaborate. And so they want to do a joint effort between our facility, because we have the ability to do live testing and live facilities. And we're also working with the facility that Total has in Europe as well. And they want to work on an ISO standard in order to have a mission testing center. So that collaboration is already happening. So the Center of Excellence, or the Methane Center of Excellence in Alberta, that's just outside of Edson, that'll be part of a collaboration with METEC and with another facility in Europe as well. So that collaboration is great, and it's well underway.
And I think maybe this is just a quick comment. I think there's an opportunity to look at some of the really big things that are happening around, say, CCUS, and as we move into things like direct air capture and other, we can look at some of the what's worked really well and say, how do we transition this into some of these other parts of the innovation economy, so to speak? And then it certainly opens the door internationally for all of us to have these types of conversations. Okay, so we've got a few minutes left, believe it or not, fellas. And so I don't know if anyone here has some questions. If not, oh yes, we got two, so we're gonna start back here. Maybe you want to start with Kevin? Okay, all right. And I'll repeat the question. Go ahead.
So, like, getting from the 45 to the 75, we kind of went from the low-lying fruit, and now there's just like hybrid. And I don't know how much there is in between. Where do you guys, if you guys were to tell an innovator where to start looking, where would you tell them to start looking to get maybe the medium fruit, or is it just the high fruit now?
Okay, so the question is, Kevin's hungry and he likes fruit. But would you guys be able to go to John's slides, because he can talk to a couple of the slides that he has, and that's actually, it's a great question, Kevin. How do we get to the 75? Where are the sources that we need to target? Because that will help guys like you and others certainly that are involved in the innovation ecosystem to say, this is where we need to direct our energy in the bright minds. And we'll get into that. But Scott, go while we pull up the slides here.
So I would say if you're picking fruit, always stop at the bottom of the tree and work all the way up. And I think there's a strange thing that's happening where people think you need to go find the tall fruit at the top of the mountain that no one's ever going to be able to get. But no, like if I was recommending to innovators, start at the bottom and just keep working your way up, because it'll have the best results from doing that.
So Jackson, the chart is on, and it's your chart that I guess you should talk about.
Yeah. Well, so part of the process that we went through at Modern West to complete this report was we looked at how did we get to 45%? And then what's it going to take? Exactly this question, Kevin, what's it going to take for us to get to 75? And so there's a lot of analysis that went into this. And then we looked at the primary emission source categories. And then we looked at where the solutions exist. And we did this sort of red light, green light situation where we're saying, okay, well, we know there's solutions within certain categories, but let's look at the size of the problem within that category. And then we can look at where the red flags are that make it very difficult. So these hard to abate emission sources, there's a lot of discussion. It's good comment, Scott, from you to say, look, just start and chip away and chip away and chip away, because eventually we'll get to the red. And you know, Kevin, you guys and any accelerator that's really trying to push things along, great opportunity to contemplate what this looks like. SCVF stands for surface casing vent flow. Yes, sir.
Well, I guess to really be able to kind of answer this question, you know, in an educated way, the best way is to start looking at the technology gaps and doing studies to see what are the opportunities are out there and how economic they are, and come back and then pick those essentially opportunities. And it's not a very linear line. I mean, it changes because you may look at tanks, some group of tanks, they may have a very simple solutions, very low hanging fruit. Some group of tanks actually would be very complex. So by kind of closing the knowledge gap is the best way to actually have a roadmap to identify your best opportunity.
Thanks. So there's an announcement that came out of COP as specific to sort of what, and I can't remember all the details, of course, but I think it was 80 some countries got together. And one of the things that they talked about from the energy sector is actually zero non-routine venting. So in the second category to the top, you see routine vents. And then most of this other stuff is a non-routine. So then it becomes up to the Scott Volks of the world and others in the sector to say, all right, well, it's not zero non-routine. Is that really going to be something that we can achieve with today's technology, or is there something else that we need to go after? And then that translates into the discussions with government to say, can we enable this, or should we actually be avoiding certain piece of a regulatory design because it's frankly just going to be too punitive? from a cost perspective, to Soheil's point around running the economics. So it's a really interesting discussion to see how we're going to get there, and we need this to continue on that path to get to 75.
So the largest ever emissions reported in Canada, because when you look at the map from the satellite, Canada is has the lowest amount of emissions when you compare all of the large oil and gas producers. But there is one area, and that was when during the blowdown of a pipeline, there was a huge amount of methane was released into the atmosphere, which was picked by satellites. As part of normal operations, you have to do those, right? So we actually worked with TC, and we developed a technology where you cannot economically eliminate that type of emissions, which was the biggest source of ever reported in Canada.
Just because I know you're an incubator and you want to have challenges, the challenges that you're looking for right now, if you want to kind of say things, methane slip-on engines is a huge challenge for incubators to work on. When you look at the proposed regulations from the federal government, they're talking about monthly detections, leak detection and repair. There just aren't enough human beings that are trained to do that. So another challenge, find technology solutions that can kind of deal with that issue as well. So like I would say if you were looking on focusing on things like that, and then there are some simpler ones where tanks are, especially controlled tanks, are more of a challenge than people give it credit for. And we need more solutions around detecting when controlled tanks are having issues as well. So specific challenges for incubation, there you go.
On the sort of positive side, from the finance guy in the room, methane emission technologies aren't very expensive compared to, say, a carbon capture, big CapEx type solutions. So the good news is with, you know, Alberta Innovates and the capital funders and the federal funders, if you've got the right solution, it won't be hard to pull that capital together and help scale your company, because they're not terribly expensive compared to other technologies to grow and scale. So that's sort of the good news to get to that 75%.
Thank you, John. So we ran out of time. Is that okay? Okay. Well, round of applause, please, for the panelists. That was excellent. And please stick around. The next session starts at 3.
Thank you, Johnson.
Thanks, guys. Good job. Great. Good job. Yeah, very good. Very good.